Hello everyone, good evening. I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU, Varanasi. Let's start the session for today. Today's topic is Fourier series in signal system. Fourier series is used to analyze any signal which is not a sinusoidal signal, or you can analyze any signal by using the Fourier series. You can find the harmonics, order, and all of the DC value of the signal. Okay, because most of the phenomena studied in the domain of engineering and science are the periodic in nature, like voltage, current in AC form, alternating current is just a periodic signal, or any cycle like a rotating motor is also there to which will rotate a speed which makes voltage changes is there in a alternative way or periodically. Because most of the phenomena domain of engineering as a periodic in nature. For an instant current and voltage in an alternating current, or you can say AC circuit in a AC circuit. This periodic function can be analyzed into their constants like a fundamental and harmonics mixture of this one constituent component. Means it will mixture of fundamental and harmonics. This process is called Fourier series analysis. A Fourier analysis. Or the periodic function. A function is a periodic of period t if the function is repeated at this time. Any function or signal is repeated after some time period. That signal is known as the periodic signal. It means the repeating signal is known as periodic signal. There is a fundamental frequency and there is a fundamental time period. If any function is repeated at time of t, after time of t, for all time t. Alex in the domain of function t. The smallest positive value of time period is called the fundamental time period. It means suppose there is a sinusoidal signal, the pi, this is 2 pi, this is 3 pi, 4 pi. If you increase the signal, it will be the same, like that, 5 pi and 6 pi. There is a negative side also there, like that. You can see here the system is repeated. This is the sign here. Then it will start again this signal. But sometime if you check this one, if you take this thing, this is a repetitive signal. Then if you take this time period and again it will be repeating like that. If you choosing any point and increasing an order, then you can see here the time period will be changed. It's depending on where you want to check take the time. If we starting from, if we taking this one to this one, this all signal also repeating this one, but there is a mentioning in the definition the smallest positive value of t. This is not a, this thing is not a smallest value of t which when the signal is repeating after this time period. That's why you have You should check where is the signal is what is the smallest time period which after that the signal will be repeated. Yes. Yeah. You have to choose the value which one is smallest repeating time for this moment. Okay. If you see here, the signal we repeated this is any signal you can take. This is also you turn to check that this is repeated. You started from here, or you could take this one. After that, this is also repeated like that. Then you have to confuse this one. Which one you have to check? Yeah, you should take. Then there is a mention here for this one. The smallest positive value of t, it means when is the smallest value. After that, the signal will repeat it. In this case, the signal is smallest value of t is this one. You start from here to here only. The signal is start repeating from here. That's why this is known as time period. It will is 2 pi. But if you check this one, the signal is started here, okay, ending here, then again signal is starting here like that. Then it will be a lot of the time period if you can choose. But actual time period, fundamental time period is this one only, which one is smallest. That's why it's mentioning in the definition. Okay. Fourier series representation is basically in three way. You can represent the Fourier series representation. You can represent in three way. First one, trigonometry. Trigonometry Fourier series representation. A polar form representation. Third one is a complex exponential. Mostly we learn about the trigonometry of type of Fourier series, which mention if the signal xt had a finite series, infinite series of periodic signal, then you can represent in Fourier series is known as uh, average value, of this signal, then harmonics, or you can see this is a variable signal. This will constant. This will be a variable frequency signal, a variable signal. First one the constant value, second one is a variable value. Constant value is the average value of that signal, then variable signal is the instem of the alternative signal like sine and cosine, which one is present in the trigonometry Fourier series. This one is denoted by a naught, and that's one is a summation of the all harmonics infinity a n cos of n omega t plus b n sin of n omega naught t, where omega naught is the fundamental frequency of the signal. Omega naught is equal to 2 pi by t, where t is fundamental time period. These three a naught, a n and b n, these three is known as the trigonometry Fourier series coefficient. Trigonometry Fourier series coefficient, and this is represented the harmonics. N represent as the harmonics present in the signal. We started from 1 because of 0 is including in the average value or DC value. This is not as the average value, DC value, mean value, anything you can say like that. And another is the harmonics is represented, which one is represented by the frequency, in term of frequency, and the magnitude of this term is variable. It's not a fixed magnitude of this one. Okay, how can you find the a naught, a n and v n for representation in the trigonometry Fourier series? How can you find the coefficient of the trigonometry? Okay, evaluation of a n or a naught. First start from the a naught. How can we represent? Suppose there is a xt represented as a naught to infinity a n cos of n omega naught t plus b n sin of n omega naught t. Then integrate the both side from a for a time period from minus t by 2 to t by 2 for taking a full time period. It means this will be integrating from for a whole time period, half time period before the 0, after that half time period. This will be a naught integration of minus t by 2 to t by 2 1 dt plus summation of n is equal to 1 to infinity a n, then integration because of a n, a naught b n is the constant value, only this one is a variable. That's why you use to integrate this one only. Not dt plus bn integration of minus of time period to half time period sine of n omega naught t into dt. Okay, this one you can integrate this one, only constant is there, then integration of this one is t limit is the t by 2 to minus of t by 2, and you can calculate easily what happened there, here and here. There are three type of system which one you want to integrate. First one, suppose half time period, or suppose there is only cos of m omega naught t. What happen if you integrate a cosine signal for a time period, and what is the answer? Integration of this one is know very well, sine, integration of cosine is sine m omega naught t divided by of m omega naught. We integrate from limit of upper limit is 2 by 2 and lower limit is minus of 2 by 2. Omega naught will be common. This will be sine m omega naught t by 2 in place of t, limit is t by 2, minus, if you take a minus here in the sine term, the sine minus theta will be minus of sine theta, and there is a minus is also here, then minus minus will be plus, sine m omega naught t divided by f 2. Then this will be a 2 by m omega naught into sine m omega naught t by 2. This will be same, you can add this one. Then what is the t in omega naught? Omega naught is equal to 2 by t. Then you can replace omega naught here, 2 by m omega naught sine m omega naught is 2 pi by t into t. T will be cancel out, and this will be 2 by m omega naught into sine m pi. Then m may be 1, 2, this will be integer value only, 1, 2, 3, 4 like that. Then what happen if you putting the m value equal to 1? The sine pi will be 0 at m is equal to 1, and if m is equal to 2, then sine 2 pi it means 360 degree, 0, sine 0 value is 0, 3 pi also 0, 4 pi also 0, it means the whole value will be 0. In this case you can say cosine signal, if we integrate from for a cycle for a time period, then the value of the integration will be 0. Is equal to 0. Okay, and same thing, what happen if a sine is there, in place of cosine, integration of same half to t by 2 sine of m omega naught t dt. Integration of sine is minus of cosine, then minus we can common here, cos of m omega naught t divided by of m omega naught minus of t by 2 to t by 2 minus 1 by m omega naught, you can common here, and this will be a cos of m omega naught t by 2 minus cos of m omega naught minus of t by 2. Cos of minus theta will be cos theta. This will be positive term, not a negative. That's why this will be positive. In this case, you can see here, this both terms are same. The integration of this one will be 0. It means sine signal and cosine signal, both the integration for a time period will be 0. Pi, 2 pi, 3 pi, 4 pi, 0, minus pi, minus of 2 pi, minus of 3 pi, minus of 4 pi, like that. Integration for a time period, it means you integrate this one to signal to this one. Time period is 2 pi for the sinusoidal. Suppose the magnitude is 1, this magnitude is minus 1. Then what happened? Integration is denoted as the area of the curve. Single integration of any function is denoted as the area under the curve. What is the area of that signal? Okay, if you integrate 2 times, then this will be represented as the volume of the for the 2 signal. Okay, area of this curve, if you integrate in this one, in this case for the sinusoidal, the, this area and this area will be same. It means this will be positive area, this will be negative area, both are same. That's why the integration for the time period will be 0. Same thing, if we talk about the cosine, this will be sinusoidal signal. What happens if cosine? Cosine simply, if you replace this one from the midpoint of this, in this case the time period started 0. Time period started from here to here. You can say this will be a minus t by 2, this will be a t by 2, minus t by 2 to t by 2. The area of this curve, this is the negative portion, this is also negative portion, this portion and this portion will be same, this is positive, these both are negative. Then positive and negative area will be same. That's why the cosine signal also have 0 value if you integrate this one for a time period. Okay, this one proved by the mathematical also. But what happen if third case? What is the third case or this one? If there is a multiplication of something like integration of minus of t by 2 to t by 2, okay, sinusoidal signal sine n omega naught t. If the multiplication of something like a cos of m omega naught t, then what happen is there? This is again 0 or there is some value. Integrate this one. Sin A cos B. In which case you find the sin A cos B. And simply you can multiply by 2, divide by 2, then you can say 2 sin A cos B. 2 sin A cos B. This will be combination of sin A plus B plus sin a minus b. This is again, this will some a constant value presenting an integer m and an integer value. The integer value presented a constant value. Any value you can say like L. Suppose you take L, this will take M or P is there. Then same thing sin L omega naught t, sin P omega naught t. Both are same thing like that. Sin n omega naught t. Integration is same for a time period. And this is also resulting is the 0 value. It means if there is sine and cosine term multiplication, there, that's why there is also the integration of these two signal is also 0. Okay. Next, what happen if a sine and sine multiplication? Next case, what happen if there is multiplication of sine omega t into sine m omega naught t dt? What will happen for this one? Again, multiply by 2, divide by 2, and 2 sine a, sine b, it will occurs in the cos function. Then 1 by 2 can common, integration of minus of t by 2 to t by 2, cos n minus m by omega t minus of cos n plus m omega naught t. This is also same, cosine, cosine, cosine in both. This is also 0. A simple integration of cosine signal for a time period, and this is also 0. Then suppose it means if n not equal to n, in this case this value will be 0. But what happen if m is equal to n? It means there are t by 2 to t by 2 sine of square n omega naught t. If sine m is equal to n, it means both are same, and sine square signal. In this case, there is not 0. You know about the sinusoidal signal. This will be cos 2t. You know about the, this will be 2 sine square t. This is also represented as 2 cos square t minus 1. This is also represented as cos square t minus of sine square t. In this case, you can use this formula, 1 minus 2 sine square t. It means you can find is the sine square t from here. Then this will be integration of minus t by 2 to t by 2. This is written as the 1 minus of cos 2 omega naught t to n omega naught t divided by of 2 dt. Okay. In this case, you can part wise break this one. Half of minus of t by 2 to t by 2 1 dt minus of integration of minus t by 2 to t by 2 cos up to n omega naught t dt. This is also same as the previous one, cos omega t integration for a time period. This is also 0. Only this one is remaining here, and this will be half t. T will be at putting the value of upper limit, lower limit. This will be t by 2 minus minus plus t by 2. This is t by 2 is the answer. Okay. If there is a sinusoidal signal and m and n both are the same, then the signal will be a sine square theta like that. Then this integration we will find from the using for by using a cos of 2t, yeah, 2 theta. Okay, same thing for the cosine signal also. Integration of minus of t by 2 to t by 2 cos m omega naught t into cos of m omega naught t dt. This is also same if m or n are not equal. This will be cos n plus m omega naught t minus cos a plus b minus of cos a minus b like that. This will be also 0 if m not equal to n. What happen if m is equal to n? Then this signal will be a sine cos of square signal. Cos square n omega naught t dt. This will be also breaking in the two part. 1 plus cos 2 n omega naught t divided by 2 and dt. This will be also t by 2. There is a five important signal when used in Fourier series. Can find it directly the value. First one, integration of sinusoidal signal for a time period will be 0. Second one, integration of cosine signal for a time period also 0. Third one, multiplication of sine and cos signal. This will be also 0. Fourth one, multiplication of same signal like a sine and omega naught t into sine m omega naught t. In this case, it will be 0 if m not equal to n, or this will be a t by 2 if m is equal to n. Last one for the cosine signal, minus of t by 2 to t by 2 cos of n omega naught t into cos of m omega naught t dt. This will be 0 if m is not equal to 0, not equal to n, and t by 2 if m is equal to n. Okay. Next is how to find the a naught. Evaluation of a naught. We know about xt is equal to a naught plus n is equal to 1 to infinity a n cos of n omega naught t plus b n sin of n omega naught t. Then integrate this one for a time period. Plus summation of n is equal to 1 to infinity a n integration of this one to half time period to full half time period cos n omega naught t into dt plus bn integration of minus t by 2 to t by 2 sin of n omega naught t dt. By the previous calculation, this will be 0 0 0 sin cos integration for a time period 0 0. This will be a naught into t. You add this one, this will be t only. Then what is the value of a naught? A naught will be calculated as 1 by t integration of minus t by 2 to t by 2 xt dt. You can integrate this one. Some of the book is represented as this one will be half. If this one will be half, then there is a 2 by t. If we represent this one by half, then this will be 2 by 2, t by 2. If you not taken as a half, this will be only a naught, then this will be only 1 by 2, 1 by t only. You can find the a naught value. Then evaluation of a n. You know about this will be the cosine. If I multiply this one is by the sinusoidal signal, then cos and sine integration of that one will be 0. Then for the finding of the a naught, a n, which one is a coefficient of the cosine signal, then you have to multiply by the cosine signal only. That's why for the this one xt, same xt is represented as a naught plus summation of n is equal to 1 to infinity a n cos of n omega naught t plus bn sin of n omega naught t. In this case, multiply by cos of m omega naught t both side, and integrating for minus of t by 2 to t by 2 for a time period. Okay, if multiply this one, then what happened? Integration this one minus of t by 2 to t by 2 xt into cos of m omega naught t dt is equal to a naught integration of minus of t by 2 to t by 2 cos of m omega naught t dt plus summation of n is equal to 1 to infinity an integration of and also from t by 2 to t by 2 cos of n omega naught t, which one is in the signal, then multiply of this one by the cos of m omega naught t dt plus bn integration of minus of t by 2 to t by 2 sin of n omega naught t into cos of m omega naught t dt. In this case, if same thing, if m is equal to n, then what happened? This will be 0 because of the alternative signal, sine and cosine. Integration of this one will be 0. Cos signal, integration of our time period also 0. Only this is remaining. Then if m is equal to n, the value of this signal will be already calculated as sine cos of square n omega naught t. Integration of this one will be t by 2. Then we can say integration of t by 2 to t by 2 is x cos of n omega naught t dt is equal to, this will be 0, this will be 2 by t by 2 an into t by 2, then an is equal to 2 by t and integration of time period minus of t by 2 to t by 2 xt cosine of n omega naught t dt. This is the formula to calculate the an after calculating the a naught. Okay, same thing you can apply for the vn also. In that case, this will be multiplied by the sine Swinnerton signal sin n omega t. If n is equal to n, then this will be cancelled out, cosine term only sine term is remaining, and the average term also 0. Then an is this one, then bn same thing, integration of minus of t by 2 to t by 2 xt, this will be a sine of n omega naught t dt, because of bn is the coefficient of the sinusoidal signal. That's why you have to multiply by the sinusoidal only. If you multiply with the cosine, then cosine and sine multiplication of cosine and the sinusoidal signal, the integration will be 0 for a time period. Okay, let's check for the example and how can you calculate the all thing, and how will you find the Fourier series. Sorry. This is the 0. Magnitude of this one, suppose A, this will be negative side is minus A. Time period is started from here to here. This will be total time period. Here you can say half of this one. Half of this one is the time period. This is the total time period T. You can divide this one in 4 sections. 1, 2, 3, 4. Then this portion will be a minus T by 4, and this will be the minus of T by 2. This is the T by 4, and this will be a minus T by 2. And minus T by 2 to T by 2 is the total time period. Then we have to calculate the A naught, A and B n for the calculating of the Fourier series. This is the half, simply T by 2. This is the T by 4, and this is also T by 4. Okay, let's calculate this one. For the A naught is 1 by T, average of this one, minus of T by 2 to T by 2 xt and dt. But here is xt is a different value at a different point. Then we have to choose the accordingly. 1 by T, the common integration of minus T by 2 to minus T by 4. Minus T by 2 to minus of T by 4 is the minus of A. Minus of A dt plus minus T by 4 to T by 0, minus of T by 4 to plus T by 4, you can say. Here to here is the same value. That's why you can take this one is the A dt plus integration of T by 4 to again T by 2 is the minus of A dt. Okay, this will be 1 by T minus of A. You can common A is all of things. Then this will be A by 2 minus of 1 or minus of T limit will be minus of T by 2 to minus of T by 4 plus of T. This limit will be a minus of T by 4 to T by 4 minus of T. This limit will be a T by 4 to T by 2. You can take a negative outside of this one. Minus T by 2, T by 4. Minus will be plus T by 2 plus T by 4. Minus will be a plus T by 4 minus T by 2 minus is plus T by 4. If there is a multiplication of negative, and this will be a positive and this will be negative. T by 4, T by 4, T by 4, T by 4 will be T minus T by 2, T by 2 will be T. This will be a 0. It means in this case the integration of the signal for a time period will be 0. It means the average value of this one will be 0. A naught is represented as the average value. Average value or DC value or mean value. Okay, it means the average of the signal. We can see here also the positive terms and negative terms will be same, then positive and negative have the same area, then average of this one will be 0. Okay, so it will be proved by the mathematical also. Second one is a an, calculation of an. This will be formula t 2 by t minus of t by 2 to t by 2 xt and cos of n omega naught t dt. Okay, again you can break this one to t by 2 common integration of minus of t by 2 to t by 2, sorry, minus of t by 4 xt equal to minus cos of n omega naught t into dt. Then minus t by 4 to t by 4 plus integration of t by 4 to t by 4 a cos of n omega naught t in dt. Again negative is there. This will be t by 4 to t by 2. Oh, sorry, this will be negative to t by 2 cosine of n omega naught t. Indication of this one cosine signal is a minus of, oh sorry, sinusoidal signal is a negative. This will be sinusoidal signal sin n omega naught t divided by of n omega naught, and the limit is minus of t by 4 t by 2 plus same thing sinusoidal signal sin of n omega naught t divided by of n omega naught. Integration of this one will be minus of t by 4 to t by 4. Again negative is there. Cos integration is the sin n omega naught t divided by of n omega naught, and this will be a t by 4 to t by 2. 2a divided by of t into n omega naught will be common. For this one, the integration is minus of t by 4 minus sin minus theta will be minus of sin theta. The sin will minus minus will be positive sin n omega naught t by 4. Again minus, this will be equal to plus, then this will be minus minus cos sin minus theta will be minus sin theta, minus plus will be minus sin n omega naught t by 2 plus here sin of n omega naught t by 4 minus minus will be plus sin of n omega naught t by 4 minus of sine n omega naught t by 2 minus minus will be plus sine of n omega naught t by 4. So 1, 2, 3, 4. 4 sine n omega naught t by 4 minus of 2 sine n omega naught t by 2. Oh, sorry, this is not a whole. We know about this will be for the omega naught will be 2 pi by t, then replace the omega naught, then this will be an. An will be 2a divided by f 2 n pi. This will be 4 sine n pi by 2 minus 2 sine n pi. Sine n pi for 0 for n integer value like 1, 2, 3 dot 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 1 pi sine pi 2 pi 3 pi 4 pi 6 5 6 7 all of the pi sinusoidal will be 0. That's why an is equal to 2 will be considered 4a by n pi sine of n pi by 2. For the n pi, there is also an is equal to 0. For n is equal to even, we will put a even value like a 0, 2, 0, 2, 4, 6, 8, 10. If putting value like that, then an value will be 0 because of the, if you putting the n is equal to 0, the sine 0 value is 0. If putting a 2, it means sine pi will be 0, sine 2 pi will be 0, sine 3 pi will be 0. If putting a even value, and if putting the odd value, then it's depending on the number of harmonics, order of harmonics, which one makes this will be positive or negative. This will be 4a divided by of n pi minus of 1 n minus of 1 by 2 or n is equal to odd number like 1, 3, 5, 7 like that. If putting value 1, then what happened? Sine pi by 2, sine pi by 2 is 1. Same thing, put here 1, n is equal to 1, 1 minus 1, 0. So minus 1 power 0 is 1. If the putting a 3, then what happened? Sine 3 pi by 2, it means 270. 270 will be a minus of 1. Same thing, put here value n is equal to 3, 3 minus 1 is equal to 2, 2 by 2 is cancel out, 1 minus 1 power 1 is will be minus 1. Okay, then this will be written as this one. Okay. For a simple rectangular waveform, A naught will be 0 because of the positive and negative area will be 0, same. A n will can calculate by this one. Then what happened? Bn. Bn also calculated by 2 by t, integration of minus of t by 2 to t by 2 xt sinusoidal of n omega naught t dt. This one also we have to break this one. Minus t by 2 to t by 2, it will started from this one will be minus t by 2 to t minus t by 4, is value is minus of a. After that this value is a, then after this one will be value of minus of a from t by 4 to t by 2. Same thing apply here. The value of a you can common 2 by t integration of minus of t by 4, sorry, minus of t by 2 2 minus of t by 4. This will be a minus of a, xt value is minus of a sin n omega naught t dt plus for the value of minus of t by 4 to t by 4, value is a sin of n omega naught t into dt. Then after integration of t by 4 to t by 2, value of xt is minus of a sin n omega naught t dt. Okay, I integrate this one. We can take common a value and 2a by t. Okay, then integration of this one will be sine, integration of sine will be minus of cosine, then minus, this minus will be positive, this will be cos of n omega naught t but by n omega naught t, because of integration of cos at is equal to integration of sine at is equal to minus of cos at divided by a. This will be minus t by 2 to limit is minus of t by 4. Again sinusoidal signal, this will be a negative part cos of n omega naught t divided by of n omega naught. This will be minus of t by 4 to t by 4. This will be minus of a, integration of this one will be minus, minus will be positive cos of n omega naught t divided by of n omega naught. This will be t by 4 to t by 2. You can take a common t into n omega naught, then this value is cos of minus theta will be cos theta, cos of n omega naught t by 2, so t by 4 minus cos of n omega naught t by 2, minus of here cos of n omega naught t by 4, minus, minus will be positive cos of n omega naught by 4 t by 4, plus here cos of n omega naught t by 2 minus cos of n omega naught t by 4. In this case you can see this omega naught t by 4 will be cancelled out from this one, this omega naught t4 will be cancelled out from this one, this omega naught t naught by 2 will be cancelled out by this one, then bn will be 0. An is there something value, bn will be 0, and what the value of xt? It will be a naught summation of n is equal to 1 to infinity an cos of n omega naught t plus bn sin of n omega naught t. For the signal a naught will be 0, not is 0, an is there, an is equal to n is equal to 1 to infinity 4a by n pi sin of n pi by 2 into cos of n omega naught t, bn will be 0. That's why the xt is represented as summation of n is equal to 1 to infinity 4a by n pi sin n pi by 2 into cosine n omega naught t. For a simple square signal started from 1, it means a positive value. In this case, the all value represented in this case is the a naught will be 0, bn is equal to 0, only an is presented. Bn is equal to 0 because of the signal is the even signal. Let's start, take an example for odd also. Another example, second. This will be 0 point, this will be a minus of a. कैसे? This will t by 2, this is t, this is the minus of t by 2, this is 3 by 2, 3 t by 2, this is minus of 3 t by 2. In this case, what is the an? A naught. A naught will be again 0. Why? Because of the this one. The area, in this case, the positive minus t by 2 to t by 2, this is the time period t. Area positive and negative both are same. That's why this will be also 0. Okay. This is negative area, this is positive area. That's why the overall average of this function will be 0. Then what is value of an? In this case, this will be 2 by t integration of minus of t by 2 to t by 2 xt cos of n omega naught t dt. This case, this system is 2 by t is breaks in two part, minus t by 2 to 0. Again the system value is changed. That's why we have to part this one into two, divide into two part. integration of minus of t by 2 to 0. This value is minus of a and cos of n omega naught t dt. Second part will be 0 to t by 2. This value is a cos of n omega naught t dt. We can take common a from this one, and this will be a 2a by t. Integration of cosine signal will be sine of set of signal n sine of n omega naught t divided by of n omega naught signal from minus of t by 2 to 0. Second signal, this is minus is there, that's why we have to take negative also here. Cosine signal, integration of cosine is the sine of set of signal. Sine of n omega naught t divided by of n omega naught from 0 to t by 2. You can take common as n omega naught, then t into n omega naught outside. Sine 0 value is 0, minus minus will be plus, then again minus t by 2 will be negative. Sine of n omega naught t by 2 plus sine of n omega naught t by 2 minus sine 0 is 0. Then what value is 0? It means an value is 0 in this case. Now what is the value of bn? Bn will be calculated as 2 by t integration of minus t by 2 to t by 2 xt sine of n omega naught t dt. Same thing, a is there, then this will be, we can common a minus t by 2 to 0. This is a negative signal minus of a, that's why this will be minus sine n omega naught t dt plus integration of 0 to t by 2 positive signal, and this will be sine of n omega naught t dt. Integration of sine n omega t is minus of cos n omega t divided by of n omega, that's why you can common n omega naught outside. Sine omega t n omega t is minus of cos, minus minus will be positive, and this will be a cos n omega naught t from minus of t by 2 to 0, and this will be minus of cos n omega naught t from 0 to t by 2. Cos 0 value is 1 minus cos of n omega naught t by 2 minus cos of n omega naught t by 2, minus minus will be positive, 0 value is 1, cos 0 value is 1. 1 is 2 cos n omega t, cos n omega t added, then this will be also 2, 2 will be outside, this will be 4a divided by of n omega naught t 1 minus of cos n omega naught t by 2. Then you know about t is equal to 2 pi by omega naught, put the value here, 4a divided by of n, or you can say 2n pi, 1 minus cos of n pi, 2 here, then this will be 2 by n pi. What happened if this will be n pi, sorry, if n is equal to even function, even it means 0, 2, 4, 6, like that. When value is 0 and cos 0 value is 1, 1, 1 minus is equal to 0, 1 minus 1 is equal to 0. If n is equal to 2, then cos 2 pi is 1, 1 minus 1 will be 0. It means if n is equal to even, then bn is equal to 0. If n is equal to odd, like 1, 3, 5, 7, dot dot to infinity, then bn is equal to, if putting the value of 1, cos pi value is minus of 1, minus of 1 minus it will be positive, 1 plus 1 is equal to 2, then this will be a 4a by n pi. It means this function will be written as a naught is will be 0, a an will be 0, then only vn function is remaining, 4a by n pi sine of n omega naught t for n belongs to odd function. By these two signal, this signal and this signal, you can observe one is the odd signal or one is the even signal. Then what happening in the even signal and what will be happening in odd signal, you can observe from these two signal. This is the even signal. Why this is the even? Even it means xt is equal to same as x of minus t. It means if you reverse this one, this signal at y axis, then the signal will be same. It means if you put a mirror here, if you will put the mirror here, then you can see this signal is same as this signal. That's why this signal will be a even signal. But in this case, yeah, you put the mirror here, then this signal is not will be same as this signal, and this signal will be xt is equal to minus of x of minus t. This is a negative of this one. It means the magnitude will be changed. We multiply by the negative, then this will be same, because of this signal will be goes to up. Then what happens if function is symmetry or not symmetrical? In this case, for the both the case, this signal will be symmetry to y axis. Symmetry signal is defined as the if the signal xt is equal to minus of x t plus minus of t by 2 is the same. How can we check this one? Simply take any one block. Suppose I have taken this block. Okay, this block, what happened? This is negatives there. It means magnitude will be a change, and this will be goes to up side. It means the same block is goes to upside because of this is the negative is here. Okay, then after you have to shift this one plus minus, or you can shift a delay, you can take a delay or advance, you can do a delay or advance. Suppose you take the positive, then you have to shift this signal is here, then this block is same as the this block. If this block is same as the this block, then the signal is known as the half wave symmetry signal, because of taken as the half only, t by 2 signal is taken, and this will be known as the half wave symmetry. In this case, the A naught value will be 0. If this type of symmetry is present in any signal, then average value of that signal will be 0. Or you can see another way, if the area of the positive curve and the area of the negative curve will be same, then that signal have also A naught value will be 0. Okay. Next one, what happen in if even signal and odd signal? If there is a even signal, then the magnitude of the Bn, which one is multiplication by the sinusoidal signal, will be 0. Bn is 0 in even signal. Okay, I makes a chart here. A naught, An, Bn, signal nature. First one, suppose signal is in general way. How can you find the A naught value? A naught average of this signal, integration of minus of t by 2 to t by 2 xt dt. En 2 by t integration of minus of t by 2 to t by 2 xt into cos of n omega naught t. Third case, Bn 2 by t integration of minus of t by 2 to t by 2 xt sine of n omega naught t. Okay, so into dt. If the signal is even, then what happened? A naught value same, En you can calculate from this one, Bn will be 0. If the function is odd, then this will be calculated, En will be 0. But if the system have half wave symmetry, in this case A naught will be 0. Then En will be calculated, Bn will be calculated. But only odd harmonics is there. Only odd harmonics is there. Even will be 0. Here only for the n is equal to odd signal, this will be this one, or even this will be 0 an, because of this have half wave symmetry. Another, this signal also have half wave symmetry. Why? You can shift this one, suppose shift to upper side, this will be here. After that we can shift left up right, then this will be overlap the original signal. In this case, this signal have a half wave symmetry. In this case, A naught will be 0 directly. Even signal, A and B n depending on the odd and even signal. This is the even signal. That's why A n is present, A naught also 0. Bn also 0. It means here A naught 0, Bn 0. Only you have to calculate An. You can see here A naught 0. You calculated the An. Yeah, An is present. This is also even for the n is equal to even harmonics, the value will be 0 because of there is the half wave symmetry. If there is a half wave symmetry, the even harmonics will be eliminated. Only the odd harmonics is present. That's why this is also odd function. For the odd harmonics, this will be the an. Okay, bn is equal to 0 because of the signal is even signal. Same thing here, this is the odd signal and half wave symmetry. Odd and half wave symmetry. It means half wave symmetry and odd signal. In this case, A naught will be 0, An will be 0, Bn is presented, but only odd harmonics is there in the Bn. Even harmonics will be eliminated. Okay. But in some of the cases, have a hidden symmetry also is there. What is the hidden symmetry? Just looks here. Suppose of the signal is there, 0, value is 2a. Okay. And what is the time period of this signal? This signal have time period started here to here. Okay, this is the time period. Or you can take the half of this one and half of this one. And the signal have time period t. Start from 0, this will be t by 4. This will be t by 2 minus of t by 4. This will be minus of t by 2. Okay. But here you can't be say this signal will be half of symmetry. You can't be say that directly. But the same signal, if you clamp the signal by value of a, it means this horizontal lines passing from a, then this will be the a, this will be the minus of a. Okay, if you adds clamp this signal by a value of a, and the horizontal line is passing the middle of this one. and this value is A, this will be a minus of A, and this signal is looks same like previous first one. This is the even signal and half wave symmetry, but this phenomenon occurs when the signal will be clamping by the value of A. The same value is represented by the ADC value, like A naught value is the A only. In this case, remaining is the same, but there is a DC value because of the clamping the signal by the value of A. Then for the even signal and half wave symmetry, then for the even signal, AN is present, AN is present, BN is 0, but only odd harmonics is there because of the half wave symmetry. AN A naught also here because of here is the hidden symmetry. That's why the value is A. The same value who clamped the signal. Then A naught is A, En we written as n is equal to 1, same to same in previous one. Okay. Suppose there is a signal, for example, so this is 0, 1, 2, 3, magnitude is 1. Find the nature of the trigonometry Fourier series. What is the nature of the Fourier series? Nature of Fourier series, it means are the AN, A naught, AN, BN, and nature of harmonics. We have to talk about this. If you calculate all of things, then you can say easily. But without calculating, how can you say? In this case, we have to check the hidden symmetry also. And how can you check? We have to clamp this one by the half. If you 0.5, if you clamp this signal. In this case, the time period this one, half of this one is this one, and half of this one. It means if you replace this signal, if it goes to upside, that this signal will be looks like that. You shift this one here and here, then the signal is not same as exactly signal. That's why there is no half wave symmetry. If there is no half wave symmetry, it means there is odd harmonics and even harmonics both. Odd and even both harmonics. But what is the value of A naught AN? In this case, A naught is a DC value because of the you have to shifting this one, and this signal is the started from 0 to here. That's why you can say the signal is even odd signal. DC value is there, okay. DC value, average value, which one is 0.5 because of this is the 1 and 2. DC value, odd and even harmonics, A naught AN is equal to 0 because of the signal is the even signal. BN is presented, it means a sinusoidal term, sine term only. You can see this is the, this is presented, this is presented, this is the 0, this is presented, harmonics is the odd and even both. Second case, suppose the second example, a signal looks like that. What happening in this case? Same 0, 1, 2 and 2 digit 1. This is the periodic signal. Yes, periodic signal. Period is repeated from here. Time period is 2. This is the half time period. You can say this is the T by 2. This is T by 2. Area of positive is same as the area of negative. That's why A naught value is 0. There is no DC term. Then the signal will be a, what happen in odd half of symmetry. Half symmetry is checked. Half symmetry is checked by uh, the signal. This portion shifted to upward. This will be here. This will be here. Then after you can shift by half or the right side or the left side. Then this signal is exactly overlapped. If this signal is exactly overlapped the original signal, then there is the half wave symmetry. If half wave symmetry is there, the system has presented only odd harmonics. Or harmonics is there. But in this case, yeah, this is the confirm, this is confirm. Then this is the odd signal or even signal. Xt is equal to minus of x minus of t. The signal is odd. Xt is equal to x minus of t. This signal is even. Check the both. First of all, put the negative signal. It means put the mirror here. Then what happened? This signal is exactly looks like the same as here. No. Then this is not even signal. Is negative of this one. It means if the negative of this one is the same as here, but can't we say the exactly the same signal because of this there is if the signal is looks like that, okay, then you can say that there is a odd signal, but the signal is be this one like that. If the shift the negative is here, then this will be this one, but the negative of this one will be negative of this one, that this will be here and here. This plus the portion is not the same exactly. That's why this is the not even signal, not odd signal. Then an and bn both are present. It means sine and cosine term both are present in this case. If the same thing is looks like that, okay, in this case there is a odd signal because of you have the negative, it means this is shifted here, then this is the negative is there, then you put the mirror image, then this will be looks same as like that. Okay, it means here is the odd harmonics plus sine and cosine both the sum, n r will be 0. Okay class, here. Okay, we'll meet the next time. Thank you everyone.